Hello, I'm Professor Nan Jokerst of Duke University, and I'd like to welcome you to Nanotechnology, a Maker's Course. Now, before we jump into our nanotechnology exploration, let's first talk about what we mean when we say nanotechnology. First, what does the word nano mean? And did I change my name to Nan when I took this job? Well, for the first question, nano means 1/billionth. So a nanometer is 1/billionth of a meter. And as to the second question, no, my parents chose that name without intuition of my future profession. But I did end up rather small in size, so it all worked out for the best. This scale bar gives you an idea of the size of different objects in our world. First, at the right side of the scale bar is the 1 meter mark. At this size we have, for example, a human. The average adult human is about 1.5 meters tall, on the short side, that's me, to nearly 2 meters tall on the tall side. Now let's move to the left along the scale bar and consider smaller objects. A mobile phone is about 0.12 meters long, or 12 centimeters long. Continuing on to smaller objects are insects, such as ants. These ants are about 2 millimeters long. So we're now at the millimeter scale, or 1/1000th of a meter. Continuing on to the left on the scale bar are even smaller objects. We have a human hair, for example, as seen under an optical or light microscope. The width of the human hair is 0.1 millimeters or 100 micrometers. In the lingo of the nano world, we call micrometers microns. Now we see bacteria here, such as E. coli, are even smaller. These bacteria have been imaged with an electron microscope, and the bacteria are about 2 microns in length. So an E. coli bacteria are about 1 million times smaller than a human. But hold on, viruses and DNA are much smaller than bacteria. So our next object here is a reconstructed image of a virus. This just isn't any old virus either. This is the rhinovirus, which is the cause of the common cold. The width of a rhinovirus is a mere 30 nanometers. That's 0.03 micrometers, which is nearly 10,000 times smaller than the diameter of a human hair. At the far left side of our scale bar, we have a DNA molecule with its characteristic helical shape. The width of the DNA helix is about 2 nanometers, which is about 1 billion times smaller than the height of a human. So back to our first question, nano, meaning 1/billionth, describes feature sizes that are about 100 nanometers and smaller, which is this left side of the scale bar. Just for fun, let's go in the other direction on our scale bar and see how big an object would be if it were not 1 billion times smaller than a human, but rather 1 billion times larger than a human. The diameter of the sun in our solar system is about 1 billion times larger than a human. That's pretty big. So the comparison between a human and DNA at the nanoscale is the same as comparing the size of the sun to us. Technology at the nanoscale is a diverse field that's part of our everyday lives, often in ways we don't realize. Nanotechnology is used in many industries. For example, consumer electronics such as laptops and mobile phones. Some fabrics use nanotechnology for stain-repellent coatings. Nanomaterials are also used in cosmetics and in construction or composites for abrasives, and in sports for high-strength, lightweight equipment. The automotive industry uses nanotechnology for structural materials and electronics, such as fuel cells and batteries. Nanomaterials are also used in applications to deliver chemicals or to filter fluids. For example, carbon nanotube-based water filters not only remove bacteria, viruses, and other contaminants from drinking water, but also they may end up being less expensive than other methods for water filtration, which is particularly important for developing regions of the world. Medical research is exploring the use of nanoparticles to deliver medications to the site of a tumor. And nanoparticles and quantum dots are being used to treat antibiotic-resistant bacteria. Nanotechnology is an enormous field that studies small feature sizes with broad applications. So we return to the question, What knowledge do we need to become a nanomaker? So let's look at some of the instruments and techniques we use to study and create at the nanoscale, which we will explore in this course. First, to create patterns at the nanoscale, we can use a beam of electrons that we steer to draw patterns with feature sizes as small as 10 nanometers. We can deposit materials that are 1 atomic layer thick, and that's less than a nanometer thick. We can even persuade atoms and molecules to arrange themselves into organized patterns with nanoscale features. In addition to creating structures, you will also learn about instruments and techniques to characterize nanoscale objects. One example of nanoscale characterization is electron microscopy, where we use electrons rather than light to create images of objects at the nanoscale. We can also learn about materials by measuring how light interacts with the material, whether the light is absorbed, is reflected, or is transmitted through the material. These are just a few examples of instruments and techniques that you will learn about during this course. New applications of nanotechnology emerge every day. The nanoproducts of tomorrow lie in your imagination. This course will demonstrate the techniques and share with you the inside information on how to fabricate and characterize at the nanoscale. Join me in learning how to become a nanomaker.